Hello everyone, and hope you're fine today. We're gonna continue what we have already begun with in the alternating sinusoidal current discussion. And this time we're gonna study the experimental and theoretical analysis of AC circuits, where we have a current equals Im sine omega t, and U of t is U of maximum, voltage maximum sine omega t plus phi. And if you can see here, there is a plus phi here. So U of t actually goes ahead from I by phi, or we can say it in other words, that U of t leads I by phi. And that's the discussion today. So let's go. We have this circuit is made up of a resistance and an inductance. And in this circuit, we have of course the voltage and the current of the alternating sinusoidal current generator connected to an inductance of voltage U of L to a resistance of voltage U of R. And we connect this circuit RL to an oscilloscope phase component ground, or phase resistance ground, phase inductance ground. And ground has to be always between the two components that are to be measured. However, I have created something that might interest you. It is Li. E is the voltage, L is the inductance, and I is the current. So the voltage leads the current by phi, or if U goes ahead with respect to I by phi, this means that I goes behind, or we say it is actually lagging. I lags U by phi. Let us determine and specify and study how is the curve gonna be on the oscilloscope. So the oscilloscope gonna show us that the current lags the voltage, or the voltage leads the current. So when we connect the oscilloscope to this circuit, the oscilloscope will give us this these oscillograms. For the brown oscillogram, it is the U of L. U of L. The current goes from B to M, so it is UBM, so it is U of L. However, the violet curve or oscillogram, it's U of R, it's actually UMA. So UMA, it is positive, but actually the oscilloscope reads phase first, then the component, then ground. That's why we make the inversion so that we get these graphs. We realize in these graphs the following. We realize that we have a maximum voltage of the inductance that is reached at point A here. So we're gonna call it T at A. And we realize that the maximum voltage of the resistance, it's at B, it's actually here at D, and we're gonna call this T at D. We realize that the maximum voltage reached of the coil reaches before the maximum voltage reached by the resistance. So this means that U of L leads U of R. However, we know that U of R is the image of I. So U of R is the image of I of R. Knowing these two facts, we can conclude the following. If U of L leads U of R, and U of R is the image of I of R, this means that U of L leads. So U of L leads I of R, because U of R and is the image of I of R. If you want to go further to determine or to designate the phasor diagram, we realize something here which is very important. we realize U of L is here, is leading I of R by phi. So this is up, this is down, so this is U of L leading I of R by phi. However, how can we find phi? From this curve, and knowing that this curve is not up to scale, and knowing that phi is negative, because U leads I by phi, or I lags U by phi, we want to determine phi. We know the equation of phi is 2 pi, and this 2 pi is for one period, times x from 1 to 2. What do we mean? 1 is curve 1, 2 is curve 2, but more specifically, 1 is this point actually. It is the peak of the first curve of U of L, and this is the peak or the maximum of U of R. The distance between C and B is known as x from 1 to 2. So it is the maximum voltage of the coil. The first one is C, and the consecutive one is the maximum voltage of U of R. So the distance here, it's given to be 5 over 2. So 2 pi times 2.5, which is 5 over 2, divisions. However, the T divisions, what do we mean by T divisions? It is the divisions of one period. So we take, for example, C and C prime from peak to peak. That's one period. Or we take it, for example, from rest to rest. This is one period. Or we take it, for example, from B here, from B to B prime, the maximum. So here we have B prime. That's actually one period. Or we take it from trough to trough. That's another period. However, the divisions of one period from B to B prime or from C to C prime is always equal. So C to C prime, it is given that it is 9 divisions. Divisions over divisions will cancel out. 2 over 2 will cancel out. This implies that phi is equal to 5 pi divided by 9 radians. And worth mentioning that radians is the unit of the angle, not degrees. Why? Because we have here omega t plus phi. So omega is in radians per second times second plus something. So second over second will cancel out, plus it has to be in radians so that it will be compatible with the angle theta, which is omega t plus phi. Now, as long as we have studied the experimental analysis of the LR circuit in an AC generator using Li, and we found the phase difference phi, let us go for the theoretical analysis. In the theoretical analysis, we know the addition of voltage is low, and you have to put it always. U of t is U of R. U of t is U of R plus U of L. So that's the addition of voltage is low, and it is Ri, Ohm's law, here. And Ohm's law for an inductor is L di over dt. It is minus d phi over dt, but minus times minus, it will be positive L di over dt. And then we put the equations. From where did they bring the equations? They are actually given. That's I here, and that's here di over dt. What's the derivative of Im sine? Here we have L, so L remains the same. L remains the same. Im as well remains the same. Here we have it. What's the derivative of Im sine omega t? It is sine. What's the derivative of sine? It is cosine omega t times the derivative of the inside, which is omega. So we'd get Lim omega cosine omega t. And then we put it um sine omega t plus phi, that's given as well, is equal Rim sine omega t plus Lim omega cosine omega t. From here on, the objective is to determine the phi and u of m. How can we do that? We have the first method. The first method, trigonometrical method, sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, or c co cos, to make it in a funny, nice way. So we are applying actually this equation here, sine omega t plus phi, this is alpha, and this is beta. So sine omega t cosine phi plus cosine omega t sine phi. We put it equal to this equation. So we are putting it in this equation. Now let us equate. So we have, these are similar equations. Sine omega t cosine phi, Rim sine omega t. So sine omega t, they are the same. So we can cancel them out. Sine omega t, these are the coefficients. So we have here sine omega t will cancel out, and then we will get cosine phi is equal Rim. That's the first equation. What about the second equation? The second equation is, we have here cosine omega t sine phi, and we have Lim omega cosine phi. So cosine phi and cosine phi will be cancelled out. What remains is u maximum sine phi, u maximum cosine omega t sine phi is equal to this cosine omega t, and this will remain. Then sine phi is equal Lim omega. From here onwards we have two equations, so we need to find phi. So if we divide sine over cosine, we will get the tangent and we will get it. So divide it. So we'll have 2 divided by 1. The left on the left is equal the right on the right. So it's L omega, so Im will cancel out, and then we will get tangent, over will cancel out. Tangent phi is L omega over R. That's how we can find phi, and phi is equal tangent inverse L omega over R. Now we want to find u of m. How to do that? We square both sides and add. So we have from these equations, this is the equation, um cosine phi squared plus, so the left squared plus the left squared is equal to the right squared plus the right squared. Okay, and then we will equate. Take squared common outside. Cosine squared phi plus sine squared phi is equal to 1. That's actually 1. And what remains is squared. So it is equal to this. Im squared, take it as common denominator or common factor, is equal R squared plus L squared omega squared. And then equating both sides, is equal Im plus or minus square root of R squared plus L squared omega squared. Of course, SI units, this is in volts, that's in ampere, that's in ohms, that's in Henry, and that's in radians per second. Then the second method. On the first method we have found actually tangent phi, and we found and that's what we wanted from the beginning. Now another method, using the particular values, using some particular values. What are these particular values? They are omega t is equal to 0, omega t is equal to pi by 2. Why? To take all the cosine axis here and to take all the sine axis here. So we have um sine phi, as we have done it previously, is equal to lim omega. So where did we substitute omega t? In the first equation. In the first equation here, as we can see, up. So um sine phi, whenever omega t is 0, so here omega t is 0, this is 0, um sine phi is equal sine 0. Sine 0 is 0, so it will be cancelled out. lim omega cosine 0 is 1. The second one, you will have um sine omega t plus pi by 2. So here phi is not 0. It is not 0, and here it is pi by 2. So um sine pi by 2 plus phi is equal to rim sine pi by 2. Sine pi by 2 is 1. Cosine pi by 2 is 0, and let us see what happens. So here rim sine, this is gonna be 1, and this is gonna be 0. So we will have um cosine omega t. Why cosine? Because sine here, sine alpha plus pi by 2, it is in the second quadrant. So because it is pi by 2, it will change to be cosine, and it is positive. Cosine omega t is equal rim. And then using these two equations, from these two equations, as we have done previously, divide 1 divide by 2, the left on the left is equal the right on the right side. So we will get actually the same answer that we have actually got previously. How to find is the same way as we have found it here. Square both sides and add. Now for the practice, please practice this problem. I of t is 5 sine 20 pi t in SI units. It is a coil. It is in series. R is 2 ohms and L is 0.02 Henry. We need to determine U of M and phi using two methods. Do this, please. Have a nice day. But before finalizing our lesson for today, I'm gonna go for a particular value in the RL circuit. What is it? It is actually when we have a purely inductive circuit. So previously we didn't have a purely inductive circuit. Previously we have an inductive circuit, RL circuit. Now we are gonna have the resistance to be 0, so we're gonna only have an inductance. So that's called purely inductive circuit. So we're gonna have only the inductance. In this case, we have U leads I by pi by 2, or I lags U by pi by 2. In this case, we're gonna see something which is similar to what we have seen previously. Substitute phi by pi by 2 here. I lags U by pi by 2, so phi is minus. There is a misconception used by or determined by students. I lags U by minus pi by 2. No. I lags U by pi by 2. This implies phi is equal to minus pi by 2 over 2. And U leads I by pi by 2. So phi is pi over 2 radians. If you want to go to the phasor diagram, it's the same as previous. It's the voltage of the inductor. That's the voltage of the inductor. And the current of the inductor, they make actually 90 degrees. They make actually 90 degrees. You are mainly responsible for everything. The phasor diagram is a clarification to know more about. May you have a nice day, and don't forget to solve the problem, which is this one. Have a nice day.